Welcome back, Common Core Algebra II. Today's lesson is 6.8, completing the square and shifting parabolas. So, completing the square and putting an equation into vertex form is something we worked pretty extensively with in Algebra 1. We work mostly with linear equations, but we're going to now use this same concept with quadratic equations. So in exercise 1, it says the function equals y equals x squared, which is generally known as the parent function, is already shown on the already graphed on the grid below. Consider the quadratic whose equation is y equals x squared minus 8x plus 18. A says, using the method of completing the square, write this equation in the form y equals x minus h squared plus k. So if you remember how to complete the square, hopefully it's not completely new to you. So we're going to start with our equation. So let's write down y equals x squared minus 8x plus 18. Now, to complete the square, what we're considering is just this piece here. We're considering the x squared minus 8x. Okay, we're going to leave the plus 18 off to the side a little bit. So what we do is we consider when we're trying to find this last piece to complete the square is we're going to take half of our linear term, which is -4, and square it. So you're going to notice that that term is always going to be positive because it's either going to be a negative times a negative or a positive times a positive. So what we're going to do here is take half of it and square it, which means we're going to add 16 to both sides. Now, I shouldn't say it to both sides. We're going to add 16, but I'm going to remind you that this is one side of the equation. So in order to maintain the integrity of this equation, we're going to, I don't know where that equal sign is coming from. I know it's my hand. Minus 16, so that way we haven't changed anything. All right, but now we can rewrite this. We can rewrite our x squared minus 8x by simply x minus 4, take half of that linear term, squared. All right, so y equals x minus 4. Now don't forget about this part. This part has to be done too, and you get plus 2. All right, so if you look at this, you can see that our h comma k is going to be the vertex of our parabola. All right, so B says, describe how the graph y equals x squared would be shifted to produce the graph of y equals x squared minus 8x plus 18. Well, again, I just finished telling you that using our formula here, I know that I'm going to change this sign to a positive 4, and I'm going to keep that positive 2 exactly the same. All right, so in order to go from 0, 0 to 4, 2, I'm going to, the parabola shifts. Right 4. And up 2 units from the parent function. From the parent function. I think I said function there for a while. Okay, so shifts. The parabola shifts. I think it's supposed to be an F. Shifts right 4 units and up 2 units from the parent function. So in other words, where it would go is up 4, over 4, up 2 to right there. All right. C says sketch the graph of this and using the vertex form. What are the coordinates of the turning point? Now we just said the coordinates are going to be 4, 2. All right, and it's basically going to be the same parabola. So we're going to go up 1, up 1. That's what we did here. Then I'm going to go over 1, up 3, over 1, up 3. And now I would normally go over 1, right, up 5, but I can't do that. So this is what it's going to look like once I'm done shifting it. All right, so I think the greatest point here to make is right here with the vertex. All right, so once you complete this square, it's the opposite sign of the x, all right, because it's x minus h. So that h has to be a positive 4, and then it's plus k, so I know that the y value has to be 2. We'll do some more, so don't worry if it's still not becoming clear to you. All right, so let's move on to exercise 2. Using your calculator and the window shown below, sketch the graphs of the simple quadratics y equals x squared, y equals 3x squared, and y equals 1/2 x squared. Now, unfortunately, you cannot do this because your calculator is tucked away safely in the classroom, so I will just quickly show you what this looks like. So the first one I'll do is y equals x squared. I'll do that one in red. So it would look something like that. All right, then we're going to do in black y equals 3x squared. So that one gets narrower, kind of looks like that. And the last one that we're going to do, we'll do, let's say, in blue, and that's y equals 1/2 x squared, and that one's going to get wider. So I'll leave that one going for now, but it would look something like this, all having the same vertex. This would be y equals 1/2 x squared. All right, so every quadratic of the form y equals ax squared has a turning point at 0, 0. Moving on. So the algorithm of completing the square works best when a equals 1 and b is even. All right? But it does work in every case, even the messy ones, when our linear term is not a nice number or we have leading coefficients, because in A, it says place each of the following quadratic functions in vertex form and identify the turning point. So the first thing you have to do when you have a leading coefficient that's not 1 is you need to factor it out, even if it turns out to be a little messy. So in this case, what I'm going to do is I'm going to factor out the 3. So I get y equals 3 parentheses. Now I don't have to factor out necessarily of that 2. So all I'm going to do right here is look at this piece right here. So factor out the 3 and we get x squared plus 4, correct? All right, and I can leave that negative 2 out the back here. So now we're going to complete the square. How do we complete the square? We're going to take half of the middle term. I'm sorry, there's an x there. I was going to say half the linear term, but there was no x. Half the linear term and square it. So half of positive 4 is positive 2, and square it is positive 4. But again, if we're going to add it there, we have to minus it out. But beware, we are really minusing out 3 times positive 4, so we're really minusing a negative, or so we're really minusing a 12. All right? Because 3 times 4 is negative 12. All right, that's positive 12, but we subtracted out. So what does this turn out to be? Y equals 3 parentheses, take half of it, x plus 2 squared minus 14. So what's the turning point? Remember, we change the sign on the x, we don't change the sign on the y. I'm just going to slide this up a little bit before we move on to B. So, first step, when you have a leading coefficient that's not 1, y equals, we're going to factor out that 2, but only from the first 2 terms. Kind of like when we factored by grouping, right? Factor out the 2, and then what do we have left over? X squared plus 3x, all right? And now we can leave that plus 1 out the back. Take half of, now this gets a little messy because we take half of 3. Let's think fraction-wise. Let's not think decimal-wise. It gets a little tricky when you think decimals. So half of 3 and square it. So half of 3, let me just show you what I'm talking about. Half of 3 is 3 halves, and then when you square it, we get 9 over 4. Just square the numerator and square the denominator. So we're going to add 9 over 4 to this side, but beware, 2 times, we have to multiply that by 2, and that becomes 9 over 2. So we have to minus out 9 over 2 on this side. So we get y equals 2 times, take half of that 3, x plus 3 halves squared plus, and when you do 1 minus 9 halves, now you can do that in your calculator if you need to, but you get 7 halves. All right? Because 1 is the same thing as 9 over 9. So 9 over 9, I'm sorry, it's 2 over 2. I'm thinking the wrong thing. Denominator is 2. So when you're doing, this is 9 over 2. So it's 2 over 2 minus 9 over 2, which is negative 7 over 2 when you're all said and done. All right, and that's why I put a plus here, and that's incorrect. Has to be a minus 7 over 2. So with this mess, all we need to know is the vertex. So the x changes, so it's negative 3 over 2. The y, and the y doesn't change, so that's negative 7 over 2. X changes, y doesn't. If you were working with decimals, which isn't impossible, you get negative 1.5 and negative 3.5. So if you're a decimal person and you do the whole thing with decimals, and you will get nice decimals if you use decimals, then that's fine too. Okay, moving on to exercise 4. This is our last exercise for this video. All right, so use the formula for the axis of symmetry. Now this is something you need to know because it's not given to us on our reference sheet. Now, this is saying use the formula for the axis of symmetry to find the turning points for each of the following quadratic functions. Now, you didn't hear this from me. It's not like I'm videotaping this or anything on YouTube, but you can do a little cheating here because you can see if you can determine sometimes, not always, but you can determine what your vertex is from your calculator. So if we went to our calculator just real quickly, because we have the time to do it. So go to your calculator and let's put in our function, which is 2x squared minus 12x plus 7. And enter. Now what I need is the table. So I'm going to do Control T, which will give me my table. And ooh, right away it comes up because you can see the symmetry right here. You can see the symmetry going around 3, negative 11, right? This is what I'm saying. Here's the symmetry, which means this has to be my vertex. Sweet. All right, so the beautiful thing is here, even though you have to do it algebraically, I know what the answer is, and so do you. So I know that the answer is 3 common negative 11. Now again, this might not always work because you might have to actually go to zoom, or you could go to maximum or minimum, and you can find what the vertex is, even if it turns out to be a decimal. All right, but to do it algebraically, you have to use the axis of symmetry to find the x, and then substitute that in to find the y. Sounds like a lot of work? It really isn't. It's not so bad. So the axis of symmetry is always x. X equals negative b over 2a. I'm going to remind you that a is the quadratic coefficient, b is the linear coefficient, and c is the constant, which we don't need here. So x is equal to negative b, which is positive 12, over 2 times a, which is 2. So it turns out to be 12 over 4, which is equal to 3, which corresponds right there with our x value. All right? So now in order to find y, I'm going to come to my, remember, y is the same thing as f of x, so it's 2x squared minus 12x plus 7. Now, when I'm all set here, I better get a negative 11 because that's what I know my answer is. So once again, I'm going to use my parentheses with my 3. And at this point, once you show that, please don't put in negative 11 here. Put this into your calculator and make sure it's equal to negative 11. All right, so once you actually show this and you show this and you have your answer here, you're done. All right, that's pretty easy. So again, you don't have your calculator at home to try B on your own, but how about I'll cheat for you? I'll give you the answer that I found in my calculator, and the answer is 10 comma 5. All right, so now using that answer, you can kind of check yourself and recognizing here what A, B, and C is. Don't flip out with the fraction. A is negative. Now you can make it negative 0.25 if you want to. And I know B is positive 5. I don't need C. So X is equal to negative B over 2A. I always write the formula down because it helps me remember it. So it's going to be negative 5 over 2 times A, which is negative 1/4. And this turns out to be negative 5 over negative 1/2, which is equal to 10. Bam! Now to find your y, we're going to do y equals negative 1/4 x squared plus 5 times x minus 20, and we're going to substitute in our x is 10 here and here. Now, if you were here, I would tell you simply put this whole thing into your calculator, and y is equal to negative 1/4, because you don't have your calculator, plus 50 minus 20, and after we do the math, we get negative 25 plus 50 minus 20, and the whole thing turns out to be 5. All right, you get 50 minus 45, which is 5. Now we have the answer there already, and you're done. So that is a great question, one that I hope you see on the Regents exam. The only thing you have to remember is what that axis of symmetry equation is. All right, but if by chance you forget that axis of symmetry equation, you always get 1 point for the answer. So writing that answer down of 10/5 is worth 1 point no matter what. Okay, so we're done with this for today. It was a quick one, so enjoy that and make good choices as always. I'll see you next time.